Well, thank you all for joining us this evening. I'd like to start off by introducing our speaker. Mike Reiners is the Key Advisory Teacher for Casio America and has been a classroom teacher for 15 years, serving as the Math Science Department Chair at Christ's Household of Faith School in St. Paul, Minnesota. He's taught courses ranging from pre-algebra through calculus and statistics, as well as science, music, and German. He's a strong advocate for the innovative use of technology as a discovery tool in the classroom. Mike has also conducted numerous workshops around the world concerning how to challenge and engage gifted math students, the writing and implementation of mathematically rich problems, and proper pedagogical use of educational technology. We're very much looking forward to hearing what he's got prepared for us. But before I hand control over to him, I really quickly want to remind everyone that in our webinars, all participants are automatically muted for the improvement of audio quality. If you have any questions, you may feel free to type them in that question pane, and I will respond to you. So again, we're glad to have Mike with us this evening. I'm going to pass control over to him. And there you go, Mike. Just there we go. I see your screen. Things look good, so it's all yours.
All right, thanks, and welcome everyone to our webinar having to do with bringing new meaning to Sketch the Graph. And what we're going to be talking about this evening is the Sketch menu, which you can see I'm circling with my cursor here above the F4 key. The text above all of these keys, F1 through F6, are accessed primarily when we're in the graphing mode. So if I move down to icon number 5 here, which is graph on the main menu, these are all commands that automatically trigger when we're inside graph. So to give you an example of that, if we go to the graph mode for a moment and graph something simple like y equals x squared and draw that graph, then even though this text is in yellow, which suggests that you would need to access it using the yellow shift key here, when we're in graph, the calculator assumes that the reason that we would be pressing these F1 through F6 keys would be to access the text that's above them. So many people are familiar with using trace and zoom and changing the view window on calculators. So the function of these keys is pretty well known, really, no matter what calculator model you're looking at. The ability to zoom in and out and zoom in a box, the ability to change view window settings and so forth. Those are pretty well known. And on the Casio models, the F5 key is also very popular, which is the graph solver. It says gsolve above it. And that allows us to find things like roots, maxima, minima, and so on. They're not very exciting on this graph, of course. A lot of them are the same, but here we can see a root at 0, 0 with just a single key press. So F1, F2, F3, and F5 are pretty commonly known on the Casio models and commonly used. What's not as commonly used is the F4 key for Sketch. So we're going to spend some time this evening going through and talking about the different options that are available in Sketch and how they can be of beneficial use to you in your classroom instruction. Let's press F4 and bring up the Sketch menu. And we can see a soft menu appearing at the bottom of the screen, which means we're going to continue to use these F1 through F6 function keys in order to access these commands. And then we also see above F6 a little right-facing arrow, and that just means that F6 is going to be used to move from page to page of these different soft menu commands. So pressing F6 reveals some additional options. Pressing F6 again reveals a couple of more, and pressing F6 a third time brings back the original set of options. So the first thing that I want to point out to you is that there are 3 pages, so to speak, of soft menu options inside the Sketch menu. And we'll just start going through them one at a time. So above F1, you see what is to many people the most confusing of the different Sketch menu choices. And it says CLS. And you'll notice that if you press CLS, the graph redraws and nothing seems to happen. And this is because CLS stands for clear sketch. So this is a key you will find yourself using frequently if you start to use some of the tools available in the sketch menu, because your graph may get cluttered. You may sketch a number of different things on top of your graph. You need to think about the sketch commands almost like using an Etch-a-Sketch. And I want you to imagine using an Etch-a-Sketch toy, but buying one where there's already a graphing grid permanently affixed to the screen and a graph permanently drawn on the graphing grid. And that you're Etch-a-Sketching on top of those elements. So that if you were to shake your Etch-a-Sketch, the sketch would go away, but the graph and the grid lines and all of those things would still be there because they're permanent. And that's really what Clear Sketch does. You can think about it as shaking your screen and using it to erase anything that you've sketched on there previously. So let's look at one of the things that we can sketch. One of the nice things that we can do with this beautiful parabolic curve here is that we can investigate tangent lines to that curve. And sometimes in calculus, or maybe even before calculus, we'd like to investigate tangent lines without having to go into a lot of detail about the mathematics of them, writing an equation of a tangent line, understanding derivative. A lot of those things may come down the line, and we just want to get at the concept of a line that touches a graph, intersecting it at exactly one point. So we'll press the F2 key for tangent. And you see in the status bar it says select run position. And that's asking us to select the position, or the x value, at which we would like to draw the tangent line. Now right now we can see in green a tangent line drawn to 0, 0. That's because the cursor has defaulted to the center of the screen. So you might think, oh, well, I've already selected a run position. Look, it's at 0, 0. But if you use the arrow keys, you'll notice that the value of x is changing by 1/10 every time, and that the y value is changing corresponding to the point of tangency. And obviously, the tangent line is itself changing as well. The purpose of select run position is that at any point where we would like to fix a tangent line and leave it permanently on screen, we simply press the execute key. You'll notice that the point 1, 1 has been marked with coordinates. And now, as we begin to move our arrow keys away from that point, the tangent line at the point 1, 1 to this parabolic curve has been permanently drawn. And one of the things that I like to use this feature for is not only to draw single tangent lines, but also to draw a series of tangent lines and show the students how the curve is really formed almost as a locus of the interior of these tangent lines. I'm a teacher in Minnesota, and we have a number of very large and active American Indian populations in Minnesota. So one of the things that you can find as you drive throughout our state, especially in the northern half of the state, is you can find a lot of trading post style general stores and convenience stores that, especially if you go to those on American Indian reservations, you'll find a lot of stores that sell dream catchers, which are the handmade crafts from American Indian culture that basically use a wooden structure, usually made with some kind of twigs or branches around the outside, and then a series of straight line drawn strings that are drawn in a pattern, not unlike what you see here. So one of the things that I'll do in my class is I'll actually use a picture like this and the drawing of tangent lines, and then we'll do a project where the students build dream catchers. And then another option that you can do off of that is you could have students bring in a dream catcher or simply look at images of them from the internet or wherever, and then ask students to try to recreate that dream catcher picture using functions or using conic sections or something on their calculators. So you can see that I have a fairly cluttered picture now, a bunch of coordinates that are running into each other and a number of different lines. And this is one of the reasons that you may appreciate having the option to clear your sketch. So we press that F4 key to bring the sketch menu up again, and then press F1 for clear sketch. You notice it's like we've shaken our Etch-a-Sketch, and away go all of the things that we superimposed on top of the graph and drew on it, sketched on it, and we have simply our graph and our grid lines in the background. One of the other features that I'd like to show you that is really nice to use in conjunction with the tangent sketching is if we press the Shift key and then the menu key to access this yellow text getting into the setup of the calculator. And we go down to the line that says derivative, and we turn the derivative setting on. We'll then exit out of the menu, the setup menu, redraw our picture, and then again go to sketch and tangent. And you'll notice now not only do we have the coordinates of the point of tangency, but we also have an indicator here of the value of dy dx. And as math teachers, we know that that value is equal to the slope of the tangent line. So again, this is really nice to use for investigation and an understanding of really what that derivative means. If we start to now move along that graph, the coordinates of the point of tangency change, but also the value of the derivative changes. And we can ask students to try to draw some kind of relationship or pattern between the value of x and the value of the derivative. Right now we can see the value of x is 0.9 and the value of the derivative is 1.8. And as we move along, we can see that there's always this doubling relationship preserved. And that gives students a better idea of why the derivative of x squared, in general for all x, is 2x. It's always twice the value of x. I really think that this kind of thing solidifies student understanding. It's an excellent way to use the sketch tool. Now let's go back into the sketch menu and let's investigate norm. So norm has to do with normal, which is the more formal mathematical term for a perpendicular line. And of course we need to use normal here because if we look at this green line, there's really nothing on our graph for this line to be perpendicular to. You could say it's perpendicular to the x-axis, but the x-axis isn't technically part of our graph. The x-axis is not part of this parabola. As we move along, we can see this norm line, this normal line, changing. And it might be difficult for students to understand what a normal line is and why it's changing and what it has to do with this curve. It's clearly attached to the curve somehow. The cursor indicates that. But what does this normal line really mean? Well, one of the things that we can do is use multiple sketch elements at the same time. So let's mark a normal line here at 0, 0 by pressing the execute key. And then let's go over to the point -1, 1 and mark a normal line there. And let's go to -1.5 and mark a normal line there. And then let's go into our sketch menu again and choose tangent. And let's mark the tangent lines at 0, 0 and at -1, 1 and at -1.5, 2.25. And now we can ask students to consider those relationships. What's going on with those green lines? It gets a little bit messy over here with -1 and -1.5. Maybe you would prefer to choose -1, 1, 0, 0, and 1, 1 as your points. But what we'd like to demonstrate to students or have them discover on their own is that the normal line is the line that is perpendicular to the tangent line at the point of tangency. And that's where the idea of normal meets our concept of perpendicular. We say that these normal lines are normal to the curve, but the idea of perpendicular comes in because they are perpendicular to the tangent line at that point. Normal is really, really nice to use for students to understand that there's an idea of perpendicular that goes beyond perpendicular. You can actually be perpendicular to a curve, so to speak. And that's going to be a major, major factor if students ever get into anything like linear algebra, a study of vectors, which seems to be creeping more and more into the high school curriculum and especially into calculus, dealing with vectors and dot products and things like that. The idea of a normal line becomes very important. So let's clear that sketch and look at the next option inside the sketch menu, which is inverse. And that's fairly self-explanatory. We have just graphed the inverse of this x squared function. Now we can have a very nice discussion about whether or not the inverse is a function. Does it pass the vertical line test? We can have a discussion about how these two curves relate to each other. It's nice that we have a square grid here so that we can start to see that y equals x relationship. And in fact, this sketch will stay on my screen until and unless something changes about the graph. So if I press the exit key, go back and look at my equation and then press draw again, you'll notice that my sketch still appears on the screen. But if I now press the exit key and on the y2 line type in y equals x, because maybe I want to see a line defining y equals x so that I can see that reflecting relationship that we know exists between a relation and its inverse. And I'm actually going to go up here and change the format of this line to be a dotted line. Nice tool that you can use. But now if we draw, I get that nice dotted line for y equals x, but you'll notice that I no longer have my sketch. Anytime you do anything that changes the graph, the viewing window, if you zoom, any of those kinds of things, your sketch will be erased because you're effectively shaking your Etch-a-Sketch. So make sure that you have your window settings exactly the way that you want them and you zoom to the degree that you want before you add your sketch. So I'm going to zoom in. I'm going to use a hotkey here. If you press the plus key on the Prism calculator, you'll zoom in automatically. And this allows me to see the intersection of this parabola with y equals x. And now I can go in and sketch the inverse. And it asks me to select which graph I'd like to graph the inverse of. You notice my parabola is flashing. If I press the up arrow, then I'm selecting that dotted line y equals x. Well, I don't want the inverse of that, so press the up arrow again to get my parabola back. Press execute to indicate that's the graph I'd like the inverse of. And now we can see a nice zoomed-in view of the reflection of the blue curve across the red dotted line to become the green curve. If we zoom out to see that more closely, you'll notice, again, as I said, the sketch disappears. It clears the sketch for you. So if we want the inverse back, we can just do sketch inverse and get that curve back very nicely. Now we've got a question from one of our participants asking back to the idea of this inverse curve and the vertical line test, if there's any nice way to show or prove that that graph doesn't pass the vertical line test. And in fact, there is from a calculator standpoint, and it is within the sketch menu. So let's go to F4 for sketch, and to the next page. And you see here a choice above F4 for vertical. Let's press F4. And here's a vertical line that you can place wherever you like. So it's very easy for us to press execute here and mark that vertical line. And now we can clearly see that we have 2 points, one down in the fourth quadrant here and one up in the first quadrant here, where a given vertical line intersects the green curve in more than one place. And that's the definition of failing the vertical line test, and therefore the inverse is not a function. However, if we use the same vertical line tool and scroll throughout the blue graph, we can see that no matter where we mark vertical lines, those green vertical lines are only intersecting the blue curve in one point. And that's why y equals x squared passes the vertical line test, suggesting that it is a function. So to answer that question, the vertical line tool inside Sketch is excellent to use for looking at particular x values and what's going on at those places. Here's an x value that maps to 2 different y values, which makes the inverse not a function. Let's clear our sketch. And then let's move on and look at some other options on that second page of the sketch menu. We've used vertical already. Horizontal functions in much the same way. This, of course, is nice to use with our original blue curve because the horizontal line test is used to determine if a function is one-to-one. And determining if a function is one-to-one is a method that we teach in order to dictate whether the function has an inverse. So this is really the same thing as what we just did in applying the vertical line test to the inverse. We can see that our graph y equals x squared does not pass the horizontal line test, and therefore the function is not one-to-one. Let's clear our sketch. F3, the F3 key allows us to sketch a circle without requiring its equation. So you see in our status bar here, we're asked to select a center point. So suppose we go down to 0, 0. We press execute to mark the center. And then it asks us to select a point on the circle. So we can move our cursor over, and suppose we have a circle that goes from 0, 0 to 2, 2. You press execute, and there's a very nice sketch of the circle. You can use this for investigations such as how many possible points can a circle intersect with a parabola. So here's an example of a circle intersecting a parabola at exactly 1 point, or excuse me, exact 2 points. And now we can experiment. You can have the students in your class play around and see if they can get a circle that intersects the parabola at only 1 point. And you may not get it exact, but the main idea here is to have the concept down. There's a circle that maybe intersects the parabola at 1 point, and even if this particular circle doesn't exactly intersect at 1 point, it doesn't matter. It's just a sketch. It's like the student's drawing on paper. Can you draw a circle that intersects the parabola at 1 point? How about a circle that intersects a parabola at 3 points, 0 points, 4 points, 5 points? And we can go through the investigation, and this is really an excellent type of discovery activity that will show you where your different students are in their learning process in your class. Can they find all of the possibilities? Who is missing which possibilities? Which things can they see, and which things can they not see? So, nice use of the circle tool. We'll clear that sketch and go back to the second page of the sketch menu. Now we've had a question come up from a participant who has asked why these two menu options are black. If you notice, all of our other menu options in the sketch menu have a white background, and these two options have a black background. And that's because all of the menu options we've used so far have had white backgrounds, and when we choose that menu option, it has immediately done something. So when we choose circle, it immediately allows us to draw a circle. When we choose horizontal, it immediately allows us to place a horizontal line. Back on the first page, it immediately cleared the sketch. It immediately created a tangent line. When you see a menu item on Casio calculators that has a dark background, that indicates that the menu goes to a submenu at that point. It will not immediately create a command. So above F1 we see plot, and it's a dark background, which means this is actually a plot submenu. We press F1, we don't immediately get to do something. We actually have to choose one of these plot options. So we have plot, plot on, plot off, and plot change. So if we choose F1 for plot, you see that it allows us to plot a point. Okay, let's go and plot the point -2, 1. Press execute, and it's very, very small, but hopefully you can see that there has been a green point placed there. And so we could continue placing points. It's a little bit easier to see if I don't place the points on particular grid lines. But this allows you to plot points in space. Fairly simple tool. If we choose something like plot on, then what will happen is when you press execute, it will begin plotting points, and it appears to be just the same as plot. And the reason that we have plot and we have plot on has to do mainly with programmatic commands. Think when people can write programs, turning a plot on, turning a plot off. There's different choices that come into play using plot and using plot on when you're writing programs. You can see functionally on the graph using plot and plot on does almost exactly the same thing. If we now go to Sketch and choose something like plot off will only work on a point that has been plotted on. So if we press off here in space, I just pressed execute, I'll press execute again, and nothing happens because there aren't any points there. But if I go to -2, 1, where I had a point before, and I press execute, it plots off. And notice that we actually have a little piece missing from this grid line. Not only does plot off delete any plotted point, but it also deletes anything that is graphed at that space. So for example, we could plot off at 0, 0, and you notice we now have a hole there. We could plot off at -1, 1, and we have a hole there. There's actually been a pixel removed from that place. So plot off can undo plot on, but it can also undo anything that's there. It's like a little miniature eraser that erases a single point on a graph, or on the background even. And notice that I've committed my cardinal sin. My students always make fun of me for this, that I will bring my laptop in and run on battery power and ignore the battery message, and then out comes the laughter from my kids when 10 minutes later my PowerPoint presentation or the video we're watching or something ends. So I won't subject you to that today. Any further questions from participants about plotting?
Nope, not so far.
All right. So now let's go on to the line menu. The line menu allows you to graph a freehand line. So when I chose line, the line menu, and then the line command, I'm asked to plot a point. So I press execute to plot a point. And now I'm going to go and plot another point. And plot another point. And it seems like that we're just plotting points again. So wait a second, you might say. I thought I was plotting a line. Why am I not seeing a line appear? Well, you're not seeing a line because line, the line command, only has to do with certain existing lines. You will find yourself using a line much, much less often than using fline. Fline stands for freehand line, and here's a reminder of that. Select starting point, and this is much more what you might think would happen when you select a line command. You're actually not drawing a line, you're drawing a line segment. And once again, we're back to our Etch-a-Sketch idea. You select the starting point, and then you select a terminal point, and that allows you to draw a line segment. This is useful for, on a curve like this, drawing something like a secant line. You don't necessarily have to draw an entire line, but we could draw a chord of this parabola, for instance, and have some discussion about that chord. What's the length of that chord? How could we determine the length of that chord? What if we don't know the 2 points? What are some properties about chords inside parabolas and their length? And I'm just going to select all of this text here and cut it so that we have a fresh space to record keystrokes. So this is what freehand line accomplishes for you. You can think of it more as a free line segment. Again, Etch-a-Sketch moving over, although you'll find it's much easier to draw diagonal line segments than it ever was in an Etch-a-Sketch. I always found myself tremendously incompetent as a child, feeling that every one of my Etch-a-Sketch diagonal lines was jagged. I had some friends that could draw some pretty amazing things, and it was only one of the many areas in which my visual art ability suffered with respect to anyone else around me. But here, it's very simple. It's just a starting point and a terminal point, and the line segment automatically draws between them. We'll clear that sketch and go on to the last page of choices on the sketch menu. So let's look at pen and text. We press F1 for pen. We're asked to select a starting point. I'm going to go out here into space and select a starting point, and now select a terminal point. And you notice that it is literally like having a pen. And this is much more like the traditional Etch-a-Sketch. It just continues to draw and continues to draw and continues to draw until you press execute again, and then it's like picking up your pen. So this can be useful in drawing things like escape diagrams for graphs. If we zoom in, again, a little more closely, exit the pen tool, and then zoom in. Of course, our sketch disappears. If we zoom in very closely here on this graph, we could use the pen tool to show something like, starting at this point on the graph and going up to the line, and then returning to the graph. Turn my pen off. Let's turn the pen back on. And intersecting the curve again. I turn my pen off again. I'm too used to drawing line segments. Pen can just stay on and stay on and stay on, and we can start to give students the idea that this point is going to be trapped We can't see this part of the screen right now, but I could turn my pen off and give the students the same idea if I just went the opposite direction. So you can give students the idea that by drawing horizontal and vertical line segments, anywhere that you would start between the line y equals x and the curve, you'd be trapped. There's no way to get out of here. You're going to get stuck at 0, 0, or at 0, or at 1, 1, depending on which direction you decide to go. This gets into the idea of escape points and actually chaos theory. But it's kind of fun to do exercises with students and ask them if a point is ever going to escape. Where would I have to have a point so that it could escape? Which direction would I have to go? And these are fairly simple ideas that lead to some very advanced mathematical concepts later. Of course, you could really use the pen tool for any kind of four-directional drawing like that. Anything that you wanted to do that was similar to an Etch-a-Sketch, you could use the pen for that. And one of my favorite tools is actually the last one for us to talk about today, which is the text tool. If I want to put text on a graph, I can go to a point and then press Shift and Alpha Lock, which allows me to type characters. And now I can type things like the word reflection. Exit and go back, and there's a nice indicator of what might be going on here, for example, when we draw the inverse. And remember, you can superimpose sketches, so it doesn't matter what order you do the sketches in. We can talk about one graph being a reflection of the other. We do have a question from a participant who's asking if there's any way to change the color of these sketching items. For instance, if you were going to do a screen capture of what you have here and use it in some materials you're handing out to students or whatnot, you may not have the ability to do color copies or color prints. You may want this to be a darker color so that it doesn't come out light and faded when the students are looking at it. And there is a way to change the sketch color. If you press Shift and Menu to get into that setup screen that we looked at before, and you scroll down until you get to some of the options that were below the initial screen, one of the things you see here is plot and line color is listed as green. So if we wanted that to be something different, we would press F1 for color. And for instance, you could always make the sketching color black. So we'll choose black and then press Exit and draw. Now our sketch has disappeared because it's going to be doing a new sketch with elements appearing in black. So now if we sketch the inverse, for instance, the inverse will now come up black. Darker, easier to see maybe, depending on how we're printing our materials. And then if we go to that pen or the text tool again, excuse me, and we want to go over here and write the word reflection, that's also going to come out in black. So you can change the color of sketch elements. However, whatever color you change them to, they must all be that color. The calculator operating system uses that to assign a similar attribute to all of the sketch elements. Everything in Sketch needs to be the same color. There are other ways, of course, of getting around that. I mean, if I wanted to sketch a vertical line that was now a different color, I could actually go into my graphing menu and change the type of this function to x equals, and then I can still have a vertical line in green, say at x equals 2. There's my green line, and now anything I sketch would be in black, and I could distinguish colors that way. So there's a lot of different ways to kind of customize using the sketch menu and some of the elements in the graphing screen with and amongst each other and customizing them to your needs. One other thing that I did want to demonstrate is that I'm going to open up a Windows window here for a moment. What I've been using to show you today is the Prism Manager for Mac, and you can see up here that this is an alpha version of the software. The software is actually in beta right now, and if you are interested in testing out the beta version of the Prism Manager software, which is native for Mac, you can contact Casio through CasioEducation.com, and I'm sure that they would be glad to help you. The full version of that software will be coming out this fall of 2012. We're very excited about that. But one of the things that I want to show you is even with older versions of Casio's calculator models or software, a lot of these sketch menu options are still available. And so I'll just start up my PC emulation here using VMware Fusion, which is one of the ways that you can emulate a PC on a Mac. And this is also demonstrating how you can run some of Casio's PC software even if you have a Mac computer. So I'm going to open up the manager software for Casio's FX9860, which is a black and white calculator. It was a calculator that immediately preceded the Prism. And I'm just going to demonstrate for you and show you how a lot of the sketch options are still there. Obviously, on a black and white calculator, you're not going to see some of the color attributes. That's one of the advantages the Prism has. But no matter which Casio calculator you have, a lot of the elements are still in the same place. And you'll see here's sketch right above F4. So if we were to graph x squared, you could use exactly the same keys that we had pressed before. You could graph it. Change my view window settings back to normal. Same graph that we would have seen before. No grid lines, no color, a little different. True, but here's the sketch menu. There's clear screen, there's tangent, there's normal, there's inverse, everything we've talked about today. Plot, line, circle, vertical, horizontal, pen, and text. Exactly the same options. So this is yet another example of the fact that if I have students in my class that are using 2, 3, 4 different Casio graphing calculator models, I could have gone through the exact same lessons and investigations, whether they had the Prism, the 9860, any of the Casio models. And I could have been asking students to press the same keys, and I could have looked at the keystrokes up on my screen, the ones that we've been recording here. A lot of arrow keys, yes. I could turn that off and on if I didn't want to see those. But they could look at those keystrokes and press exactly the same keys on a totally different model of Casio calculator and get the same results. So it really facilitates a classroom where more and more in these days, students are not all going to have the same model of calculator. But Casio's made a lot of efforts in its line to make sure that no matter what calculator is in the room, that the same keystrokes can be used and that you don't have to differentiate your instruction. In that way, you can focus more on differentiating your instruction for different students and their abilities and their understanding of mathematics rather than what tool they happen to have in their hand. Are there any other questions from participants tonight about anything we've talked about in the sketch menu or anything that's come up or thoughts that you might have had?
Nope, no questions so far, Mike.
All right, well, then I'll thank everybody for attending. This webinar is being recorded, so it will be available on Casio's website if you'd like to review some of what we went through tonight later, or maybe you're someone now watching this webinar later and missed the original live broadcast. But Casio stores all of its webinars for teachers to use and view and learn about our products. You can check out not only this webinar but others that have been recorded. Our library is growing every day at CasioEducation.com under Educator Resources. You'll find a library of those webinars. Thank you all very much for coming, and hopefully you've now learned a little bit of a different meaning of sketch the graph.
Thank you very much, Mike, and thanks also again to all of you who attended. Hope you enjoyed this, and as Mike said, there's lots of great materials at CasioEducation.com. We have an online course for the Prism where you can learn more about that, as well as webinars and so forth. And if you have any questions, feel free to contact me at naustin@casio.com. That's Naustin @casio.com. So thanks a lot to everybody, and have a good evening.